Hi everyone, this is the gas walkthrough for July 26th. I'm Philip Newman. Today I'm solving It's Time by Bill Murphy. This is a killer Sudoku. We have normal Sudoku rules, 1 to 9 in each row, column, and 3x3 box. Additionally, we have cages in the grid. And digits can't repeat in these cages. Doesn't matter for this particular puzzle because all of them are 2-cell. Whenever you have 2-cell cages, they're going to be in the same column or in the same row. And in fact, all of these are in the same box as each other. But the important thing is the digits must sum to the total given in the top left corner. So these two digits sum to 10. And those are the rules. Like we often do with Killer Sudoku, we're going to start with the lowest cages and the highest cages. We have 3 here. There's only one way to do that in 2 cells, and that's 1, 2. There's also only one way to do 4. It has to be 1, 3 because you can't do 2, 2. And because there's a 1 in one of these cells, this can't be 1. So that resolves that. The 7 in 2 cells can have 3 different combinations. Could be 1, 6, 2, 5, or 3, 4. 2 of those are ruled out though because we have a 1 and 2 in the box. And this must be 4, 3. The 3 resolves the order here. So this is another common thing to look for in Killer Sudoku. You can just look at these 2 cages together, and they sum to 10, so you know they must be 1, 2, 3, 4, because that's the lowest you can put in 4 cells that all see each other. The 7 is going to work similarly. I always have trouble saying that word. We can't have 1, 6, or 3, 4 this time. This must be 2, 5. And if we sum these sum to 11. There's only one way to do 11 in 4 cells. 1, 2, 3, 5. 17 in 2 cells must be 8, 9. And we have a 9 there. 16 must be 7, 9. And then the 14 now can't be 5, 9, so it must be 6, 8 in this order. All right. We can do something else, I'm sure. Just going to go with what I saw. This is actually the second time I'm recording this morning. I've been having some issues with OBS, and it shifted the grid over. And in fact, I'm going to have to go back and record one of the previous puzzles because I didn't realize it did that. Anyway, I saw this first earlier when I was doing it. 9 in these 3 boxes. 9 can't go in these cells. So 9 must go in one of these 3 cells, and it can't go in the 9 cage, so it must go here. But now 8 also can't go in these cells, so it must go in the 9 cage with a 1. 1 can't go in the 12 cage, and then 3 must go in the 12 cage, so it goes with the 9. And that gets us going there. There's a 9 and 5 in this column, so 5, 9 have to go together up here. The other thing that I saw early on, the 9 cage up here can't be 3, 6, 2, 7, or 1, 8. So it must be 4, 5, and there's a 4 here. And then the 11 can't be 2, 9, 3, 8, or 4, 7. It must be 5, 6, and that places 5 there. That resolves our 9, 5 here. 1 is going to go in one of these cells. Alright, this is 6, 7, 8, so that leaves 4 in the cell. 8 and 9 can't go in these cells, so they must go here. And the 6 places 7 and 6. This has to be 8 now. The 1 rules out 1, 4 from the 5 cage, so this is 2, 3. These are 2, 4, 7, but now we have a 2 here, we have a 7 here, so this must be the 4. These are 5 and 6, which we can do. What next? This must be 3. We have 4 through 9 here, and then we have a 1 and 2 there. So that's 3. This is 2, 6, and 7. And this is a 1-2 pair, but there's a 2 here. So that resolves those. Now we have roping. If you're not familiar with roping, because I have 2, 6, 7 in both of these triples, they must go here together. And you can see we have both the same thing with 1, 8, 9, and we're going to have the same thing with 3, 4, 5. These are 3, 4, 5. These are 2, 6, 7. And which of these adds to 9 with the 2? It's the 7. And I typed the wrong thing, of course. So this is 6. Then we have a 7 over here anyway. And we had a 6 over here. We could just place the 2. These are 3 and 4. This is not 5. This is not 5. So this is. These are 1, 3. The 1 resolves 3, 1, 4, 3. The 9 resolves the 8, 9. That's going to give us 7, 8 here, and 2, 4, 6 across the middle. Alright, the 2 here gives us 7 and 2. That 2 means this can no longer be 2, 9. It already couldn't be 5, 6, or 3, 8, so it must be 4, 7. That resolves 3, 4, 3, and 9. This is 1. 1 had to go here anyway because it couldn't go in the 11 cage, and we had the other 2 1s. These are 5, 8, 9, and we have given 5, 9, so that's the 8. And I suspect that's why these givens are where they are. There may be more to it than that, but I suspect it was necessary to disambiguate the middle. Alright, what can we do up here? This can't be 3, 8, 4, 7, or 5, 6. It must be 2, 9, and we can resolve that. Gives us 3 and 2, gives us a 2 here. The 10 cage can't be 1, 9, 2, 8, or 3, 7. This must be 4, 6. We know the order of that from the 6. That's also going to give us 7 and 8. The 2 resolves 6 and 2, 6 and 7. This is 5. I'm going to resolve these down here. This is 1 or 8, which I think we can do quite yet. The 1 here gives us 3, 1. 7 or 8. The 6 here gives us 4, 7, 4, 6. And now in this column we need a 3 still, so that's going to go there. And we have a 1 here. That's going to finish our 1, 8s, and we just have a 1 and a 7. Finish it off. And that's the solution. I thought this was a really clever puzzle. I also liked how Bill avoided the symmetry here just a little bit. It's the same type of deduction here with the low and the high cages, but the 3 and the 16 are not the symmetric equivalents. And so that gives the beginning a little bit of a difference. You have to be careful. You can't just automatically fill things in. We do rely on symmetry a lot. I know that. But I really like that aspect of this puzzle. I hope you enjoyed it as well. Let us know how you did in the comments, and I will see you next time.